Okay. So in this lecture, I'm going to discuss about ADC0804 and its interfacing with 8051. So here basically I'm going to write one assembly language program to do interfacing of this ADC0804 with 8051. Now before going to this interfacing assembly language code, just give me a brief idea about ADC0804 and its pins. So basically, from the name itself, you can easily understand this is used for analog to digital conversion. So if you have followed my previous lecture, there I talked about one more ADC, that was ADC 0809. Okay. So other than that, this configuration also used in many of the cases. So in the ADC 0809 case, there are some different pin functions were there. In ADC 0804, here some different pins are there, which are somewhat different than ADC 0809. So in total here, 20 pins are available in ADC 0804 IC. So the first thing is a CS bar. CS bar is basically used it names from the name itself you can understand that CS stands for chip select. So this is you have to make it ground or you have to connect it to ground to active the 0804. Then followed by RD bar. RD stands for read. So you have to make this pin high and then low after some time. So this will bring the data from internal register to the output pin after conversion. Okay, so in ADC, basically what we are trying to do, we'll give some analog voltage and we'll try to get it corresponding digital value. So after the conversion, this read bar pin is basically used to take the value from the internal register to the output pin. Okay, so whatever the digital data you got, that will be taken from internal register to the output pin after conversion. Then write bar. Write bar is basically used to start the conversion. So how to start the conversion? In write bar, you need to give a signal. You have to make a transition from low to high to start the conversion. Okay. Start the conversion of analog to digital signal. So what analog signal you have, that you will give it to this terminal V in plus, and you have to activate this right bar line. How to activate this right bar line? You need to make a low to high transition. Okay, then conversion will start. Okay, then how to check whether conversion over or not? This will be done by this pin. INTR bar pin is showing that thing. So when the conversion is going on, it will show a value of 1 in INTR bar pin. But when the conversion is over, it will automatically change to 0, and from there you need to understand conversion is over. Okay. Then pin number 4, where you are giving the clock signal. Then V in minus, it has to be connected to ground. Then analog ground. Then this one is digital ground, and V reference by 2. This is very important pin of this ADC. Basically, this will give you the range of input voltage, what voltage you can apply. The range will be provided by this VRF by 2. Now, if you don't connect anything to pin number 9, then if the voltage what you are applying in pin number 20, if it is 5 volt, so it means your input voltage range will be within the range of 0 to 5 volt. Okay, whatever it is. So that voltage will be 0 to 5 volt. So that is defined by V reference by 2. Okay. And accordingly, for the other voltage also, if you get different voltage here and that range, what input voltage range you can apply, that is defined by this VRF by 2 pin. Okay. Then this is clock terminal. Then these are the data lines DV0 to DV6. And DV0 is the LSB bit and DV7 is the MSB bit. These are the 8 data lines that has to be connected to some port of 8051 for the interfacing purpose. So this is some basic idea about ADC0804 and its pins. Now we shall see what are the steps to be followed to write the assembly language program. Okay, to do the interfacing between 0804 and 8051. Now, these are the steps you need to follow. First of all, give a signal that is low to high pulse in right bar. Okay, to start the conversion. So, to start the conversion in this pin, you have to give a signal where the transition should be from 0 to 1. Okay, then, so what it will do, it will start the conversion. What conversion? Analog to digital signal conversion. Now, how to understand conversion is over or not? If you can remember, just few minutes before I told INTR pin you need to check. So if INTR pin, if the value is coming in that particular pin, the value is 1, so you need to understand that conversion is going on. If it becomes 0, you need to understand that conversion is over. So when the conversion is over, immediately you need to make chip select equal to 0, CS bar equal to 0, CS bar equal to 0 to activate this ADC. That is the procedure followed. Then finally, you have to make a high to low transition to the RD bar. RD stands for read bar. Okay. So you have to make a high to low transition, that is from 1 to 0 transition you need to apply. That is the signal from high to low you need to apply to get the data out of ADC. Okay. So these are the 4 steps followed to write a assembly language code for the interfacing of this 0804 with 8051. Now, here this is the assembly language code, and here I have considered that I am connecting the P1 port of 8051. The P1 port of 8051 is connected to this D0 to D7, the data line of ADC. Here actually this is denoted by DV0 to DV0 to DV7. The meaning is exactly same only. This is the data line. D0 to D7 of ADC. Then P2.1, I'm considering that I've connected to right bar of ADC, P2.2 INTR bar of ADC, then P2.3 CS bar of ADC, P2.4 of P2.4 is connected to RD bar of ADC, and P0 means P0 port is connected to 8 LEDs to show the converted digital value. Okay, so in the left side, these are the different ports of 8051, and in the right side, how I have done the connection this port with these different pins of ADC. Okay, I think you can understand. Again, I am telling P1 is the port of 8051 that is connected to D0 to D7 line of ADC. Likewise, P2.1 is the port to pin number 1 of 8051 that is connected to right bar of ADC, and so on. And finally, P0 is connected to 8 LEDs to show the converted digital value. Okay. Now, how to write the code? ORG000H that you know. Then I am using P1 as an input for 8051. The signal, the converted analog input is taken in, converted digital value is taken in P1 port. So that is connected to D0 to D7 line of ADC. That's why P1 is configured as input. Now, if you can remember in the previous lecture also I mentioned many times, if some port of 8051 is configured as an input, you have to assign a value of 0FF. Now, the second thing, no, it should not be P2, it should be P0. Now, my P0 port of 8051 is connected to some LEDs to show the converted digital value. So, I am considering P0 is my output port because some LEDs are connected there where I am going to show the converted digital value. So, move P0, 00H. Why it is taken as 00H? Because the output means if we take some, if you consider one port as an output, so we need to assign 00 there. That I mentioned many times in my previous lectures also. Then after that, if you can remember what you need to do, that read bar line, you have to give a transition from high to low. If you can remember in the read bar, just few minutes before I told, in read bar, you have to give a transition from high to low. So initially I am making it high, and read bar was connected to, if you can remember, read bar was connected to P2.4. So set B P2.4, that is high. Then after that, so I'm making ready my this one, this read bar line as high by using set B P2.4. Then after that, what I have to do, I need to start my conversion. How to start my conversion? I need to activate the right bar line. What I need to do in right bar line? Right bar is connected to P2.1. Just few minutes before I told. What do you need to do in right bar line? You have to make a transition from low to high. Just few minutes before I told. Right bar line has to be low to high. So what I'm doing here, CLRP 2.1. Set VP 2.5. So there is a transition from low to high. This is low, this is high. Okay. 2.1 is nothing but your right bar line. Sorry. Okay. So this is right bar, not read bar. This should be right bar line, low to high transition. Now, then after activating this right bar line by making a transition from 0 to 1, what you have to do, you have to check whether conversion is over or not. Which pin is used to check that one? INTR bar, just few minutes before I told. So that is connected to P2.2. So jump bit P2.2. So until you are getting P2.2 as 0, you have to make a self loop. Here you need to do iteration. Okay. Now, when P2.2 becomes 0, it means conversion is over. You need to come out from this loop. Now, after that, what you have to do? You need to immediately activate the CS bar line. So, where CS bar is connected? P2.3. How to activate it? Make it clear. CLR P2.3. And after that, what you have to do? If you can remember what we have to do for RD bar line, I told in the beginning, RD bar, I had initially made it 1. Now, I have to make it 0 to activate my RD bar line. RD bar line has to be from 0 to 1 transition should be there. So initially I made it 1 and now, sorry, 1 to 0 transition should be there. So initially the value was taken as 1. Now here CLRP 2.4. So I have made it 0. So now as the converted value is taken from the internal register, what I can do, uh, as my D0 to D7 lines are connected to P1 port of 8051, I am taking the data from P1 port to my accumulator. So move A comma P1, and then the accumulator value I can show it to P0 port where some LEDs are connected. So I am taking the value as move P0 comma A. So what I am doing, the current value of accumulator is taken to the P0 port where LEDs are connected to show the converted digital value. And you need to keep on iterating these steps again and again, because some analog signals will be coming again and again as an input. So short jump main is here. So you need to iterate this process again and again for each of the analog value. So hopefully all of you understood this video. Thank you so much.